constant in this world? Then my answer would be change, परिवर्तन. In Hindi, कहते हैं दुनिया में परिवर्तन ही स्थिर है. The change is the only constant thing in this world.
Yeah.
And so is the technology. With the advent of Industry 4.0, we are at a verge of technical revolution. The face of maritime industry is also changing. But the pace at which these changes are happening are a bit slow, and the adaptation is also slow. Indian Institution of Engineers India, IEI's Marine Engineering Division Board, MRDB, is constantly taking efforts to promote this excellence in the maritime domain. MRDB's chairman, Commander Dr. Bhaskar Bhandarkar sir, he has very enthusiastically taken up this Herculean task to confirm the availability of distinguished personnel from the industry to share their vision, and he has organized this webinar, leveraging technology for shipbuilding and ship repairs. So I would like to express my gratitude towards the guest at this forum. So we have among us Indian Naval retired Captain S.K. Patnaik sir as the chief guest. Is the advisor to IIT Mumbai Innovation Schools. Captain Patnaik sir, during his 25 years of illustrious service to the Indian Navy, was conferred with Seva Medal by President of India year 1992. Welcome, sir.
Thank you. Thank you.
Our guest of honor tonight is Indian Naval retired Commander Professor Dr. Avikshit. So he's the Dean, University School of Management Studies, Red Bara University, Mohali, Chandigarh. The former Senior VP and Deputy Chief of Ordnance Chief Officer at Reliance Shipbuilding. We welcome you, sir.
Thank you so much. Thank you.
The moderator for this evening is again Indian Naval retired Commodore, Mr. Uday Talwalkar. He is a technical advisor at Bharat Forge Limited, Pune, Director General, Naval Trials and Acceptance Authority at Indian Navy.
Thank you very much.
Among us, we also have Dr. Hemant O. Thakare, the President of Institution of Engineers India, for a presidential address. Welcome, sir. Dr. Ranganathan, Chairman, Committee for Advancement of Technology and Engineering, IEI, is also invited to present his views, but he is traveling to Madurai to join the Environmental Division Conference. So I doubt if he can make up for the meeting. Today, on behalf of MRDB, I would also like to express my gratitude towards two of our important panel speakers. Mr. Atul Mohan Raizada, the founder of Kenmark Technical Solutions, and Chief Engineer Sanjeev Mehra, Managing Director, Kenmark Technical Solutions. Welcome, sir.
Thank you.
Kenmark Technical Solutions is specialized in industrial power plant and marine services like shipbuilding, hull fabrication, vessel surveys, power plant maintenance, overhauls, workshop, and in situ repairs. So I also welcome the knowledgeable personalities in the audience and those attending this webinar from different time zones abroad. I hope today's session brings out this inspirational ideas, and through the fruitful discussion, marine professionals, training institutions, faculties, students will be immensely benefited from these deliberations. So I hope you all enjoy these exciting speakers tonight. And now I welcome MRDB's chairman, Commander B.M. Bhandarkar, sir, to address us. So over to you, sir.
Respected chief guest, Honorable Captain S.K. Patnaik, sir, who has devoted 4 decades of his quality life for promoting excellence in marine engineering, shipbuilding, and motivated marine engineers like me. Guest of honor, Professor Commander Dr. Abhishek, acclaimed submariner, shipbuilder, and prolific academician. Commodore Uday Talwekar, the visionary computer engineer from IIT Bombay, distinguished mariner whose sagacity is driving excellence in the new generation of marine engineers. Engineers, Atul Mohan Raijada sir, and my friend Sanju Mehra, who is also Secretary of Institution of Marine Engineers, Mumbai chapter. Mr. Raijada is the founder and Mr. Sanju is Managing Director of Kenmark Technology. Kenmark Technology is the trusted name for the quality repairs in marine engineering. Engineer Mahesh Patil, whose quality quest is inculcating new dimensions of excellence in the budding marine engineers at Samudra Maritime Academy. Dr. Saxena, Dr. Bindu Mohan, Engineer Kannar, distinguished members of Institution of Engineers and the Institute of Marine Engineers India, distinguished guests, participants, media, dear students, staff of engineering headquarters, ladies and gentlemen. This gives me immense pleasure to extend my best wishes to all the participants of the most relevant and happening webinar. Nearly 90% of world trade is through waterways. Waterways are found to be cost effective as well as environmentally friendly means of transporting freight. The basic needs of human like food, shelter, and minerals are going to provide by water bodies comprising of 71% of water. Oceans hold 96.5% of this. In the maritime sector, many technologies like 3D printing, robotics, 3D modeling of ship design, modular construction, usage of advanced materials, virtual and augmented reality, LNG propulsion, the high velocity, high temperature coating can shift the cost consideration of shipbuilding. Leveraging this technology in concert with artificial intelligence, modeling and simulation will lead to the digital ship. The diligence in digital ships would emerge as the most responsive way of dealing with the ever-evolving training needs of the workers at the affordable cost and also at the convenient time. Marine Engineering Division, Institution of Engineers, in its efforts to promote the excellence in the maritime domain, has facilitated the availability of distinguished personality from shipbuilding and the ship repair industries to share their vision on these important topics. I am confident that participants will be immensely benefited from this deliberation. I wish you all a grand take-home content. Shanav Varuna, Jai Hind. Now, I request moderator Commodore Uday Talwekar to kindly take the stage and commence the proceedings. Commodore Uday Talwekar, please.
Thank you, Bhaskar. I hope my audio is clear to all of you.
Yeah, you're loud and clear.
Yeah, okay. So with the permission of the chair, today we have gathered here for a seminar on a very relevant topic, leveraging technology for shipbuilding and ship repairs. You are aware that the sea offers a very good medium for transportation, and more than 70% of the world trade, and particularly in the Indian context, the Indian trade, is through sea lines of communication. The bulk carriers which carry crude, which carry energy, which carry food grains, there are a number of items which are carried, including vehicles, etc., are all through sea. The importance of sea and importance of trade through sea, we need not give more emphasis. But when we talk of this trade, we also need to look at the assets available to undertake this trade. There are the biggest asset what we are looking at today are the ships. There are various types of ships, small ships to very large container carriers. And the number of these carriers or the ships and their operation and their maintenance, both aspects need to be looked at. The technology has a very high impact on our life. Now just look at the type of ships what we had been having. In the olden days, way back in Ramayana, there have been wooden logs used for floating in the sea. We had in the times of Chhatrapati Shivaji, we had gurabs and galbats. Subsequently, we migrated to steel hulls. From the oars or the manual power, we migrated to wind, sails, subsequently to steam, and then to diesel. For a merchant liner, diesel is a very widely used means of propulsion, but when it comes to warships, we have a wide variety: gas turbines, diesel engines, steam turbines, pump jets, electric motor propulsion, and a combination of all this. It is quite obvious that technology has played a very significant role in the ship construction as well as ship operation and maintenance. When we talk of these technology changes, we need to be aware that the technology is to be used for our benefit. We need to be masters of this technology, and the technology should not be our masters. Now with this, I will like to give a brief about the events which are going to occur today. We are going to have a presentation by distinguished faculty, which consists of Shri Atul Mohan Raizada and Shri Sanjeev Mehra. They will be making a common presentation. This will be followed by a presentation by Professor Avikshit, and then in the end, we will have Captain Patnaik sir giving his views on the ship operation, shipbuilding, and his experience today. I will see Atul Mohan. He is a distinguished mariner, multi on behalf of several flag states. He also has good experience on industrial inspection of heat exchangers, pressure vessels, large cryogenic storage tanks, pressure piping. He is a QMS lead auditor, senior surveyor in charge for LRQA. He is the founder of Kenmark Technology Solutions, involved in surveys, third-party inspection, repair, reconditioning, and supply of marine diesel engine spares. He has developed a quality management system for his company and conducted training and internal audits. Competency for state from South Tyneside, UK. He has completed his higher diploma in ship management before coming ashore. He has a glorious sailing career from 5th engineer to being dry docking superintendent with Barber Ship Management, Norway. He also had the opportunity of being superintendent insurance claims, superintendent technical, superintendent yard and new takeover ships, and he also specializes in engine performance analysis. He has taken over many new construction ships from the Japanese yard, and most of them have been biggest tankers in the world. Currently, he is Managing Director, Kenmark Technology Solutions. In fact, if I have to say it in one word about him, if no one can do it, Mehra Saab can do it. Kenmark Technology Solutions specializes in reconditioning and repair, supplying all marine diesel engine spares, operation and maintenance of power plants, in-situ grinding, onboard consultancy, and so on. He is a founder member and honorary president of Amazon Nautical Association, and he is honorary secretary of Institution of Marine Engineers, India, Mumbai branch, and a member and chartered engineer of Institution of Engineers. May I now request both the speakers to deliver their lecture.
Thank you, sir, for your kind words. I will start off with the presentation. Before I start, with the permission of the chair, I would like to brief about the event that we have in the Institution of Marine Engineers. We have a quadrennial event in Marco 2022, which we are going to host in Mumbai. Just for the benefit of all the viewers, I would like to put it on the screen. So Inmarco is basically it started in 1982. It's a quadrennial event, and it's been a very popular global platform for all interactions, brainstormings, and exchange of ideas. This is happening in November, from 17th to 19th November at Sapphire, Sahara Sapphire, that's Hotel Sahara Star. The theme for the event is Evolving Maritime World for Greener and Sustainable Future. So I'll request engineers all over India who are watching, attending, if they can participate. They can be delegates. We have a students' corner. We have exhibition stalls for people who want to have their products displayed. We have supporters of various kinds and advertisers. Thank you. I'll start off with the main presentation. Atul sir, over to you.
Very good evening. We at Kenmark Tech Solutions have a quality policy, and I'll just read out for your benefit. First one, to be preferred service provider of spares, repairs, overhauls, ships, machinery, power plants, and industry. We endeavor to satisfy the needs and expectations of the customers consistently and ensuring regulatory and statutory requirements are fulfilled in all aspects of our service. We will at all times adhere to the quality management system and its requirements, and will monitor and continually improve its effectiveness in all aspects of business. Well, the important thing is the ship must keep moving. If the ship stalls, the complete related industry will collapse. This is the high point of our Kenmark. Our USP, we are certified to ISO 9001, 2015. We have class approved procedures in the workshop. Our prices are very competitive, and we maintain very high quality standards in our all operations. Another important aspect of our service is timely delivery. And we also provide warranty on our services. We have competent and experienced personnel on board and in workshop, regular feedbacks from clients incorporated in our monthly meetings to improve our services. Our feedback forms are available on our website. We have an SISC Chrysler rating of SE3A. We have received awards including Udyog Pratibha Award and Rashtriya Udyog Ratan Award. Now we come to the restoration of the worn out parts or damaged parts. It is like doing punarjan on them. Metallurgical and physical properties as well as dimensional accuracy is maintained. And the idea is that they are economical as compared to a new product. Lead time to new products and spares could put the vessel out of operation. Number 3, accessibility of availability of spares in ports, that is coastal. So we are able to move the repaired part easily. Custom duty or other costs for spares to reach the ports. With OPEX costs scaling down day by day, saving money is of prime importance to the ship owner, ensuring that the vessel does not have breakdowns. So our mantra is go green, recycle your own products. Okay, these are the important points for looking after engine room machinery. If they are well attended, they give long working life. Regular plant maintenance schedules routine help in maintaining the machinery in good shape. Number 3, using good quality spares goes a long way. Number 4, well lubricated, using the correct grade of oil and good quality of lube oil helps in maintaining many components in good shape. Low sulfur fuel nowadays is biggest villain nowadays in the operations. Trained personnel, regular training and updating to new technology is a must for all engineers. Training never stops. Material failure in many cases leads to a component failure. Despite all above factors in place, there will be certain wear and tear in the machinery, which we would consider normal, and maybe some unprecedented events that can lead to various components needing attention. Now, these are the type of components we are able to attend in our workshop. Cylinder covers, cylinder heads for both 2 and 4 stroke engines. Cylinder cover jackets, again for both 2 and 4 stroke engines. Number 3, connecting rods, piston rods for 2 and 4 stroke engines. Spinners, pistons, exhaust valve spindles, seats and cages, cast iron casings, and jammed components which we receive quite often in our workshop. In situ grinding of crankshafts on board the ships, pump casing, shafts and impellers.
Thank you, Atul sir.
I'll hand over to Sanjeev to go over the repairs and restoration. Thank you.
Thank you, sir. We'll take it one by one. So take it on cylinder covers. What we're going to talk about is what kind of repairs that we usually do on these components. This will be of help not only to students and to superintendents or people who are sailing, but basically general knowledge to all the seafarers of what kind of problems that one faces on these components. I will try and touch upon the commercial issues also, which basically is more relevant and people love to hear figures, and as we go along we'll take it as it comes. So starting off with two-stroke cylinder covers. So there are about 8 problems that we normally face. Starting off with the first one, that's erosion in way of O-ring seating area, in way of jackets, and in way of exhaust valve seats. Cracks in air start valve pockets in the combustion area. Cracks in the fuel valve pockets of seating of fuel valve in pocket, damaged or dimensional problems. Liner seating areas get damaged. Water connection holes get eroded and seating surfaces get damaged. Broken high tensile studs for fuel injectors or exhaust valves. Damaged threadings, various seatings which are there in the cylinder cover, and choked bore cooling holes. So here are some photographs. Basically, I will try and take it along of what all we are facing here. So here you can see, one second. So here you can see seating areas are damaged. Here you have damage in the O-ring grooves. This is absolutely worn out. If you see, this is absolutely worn out here. These are cooling connections. These are cooling connections, and this is basically your threading holes for the studs. Combustion area, you can see where the fuel injector comes out. So there's a big crack here. The cladding area, this is a cladding area here. This is a cladding area which is damaged, which is eroded. This is fuel valve pockets with lot of lapping, lot of emery being used. The sizes get distorted, so you have a lot of problems here, or you have cracks in them. These are peculiar to Wärtsilä engines. You can see cracks because Wärtsilä has got bore cooling, and very peculiar problem with these heads. The thickness is in the range of about 20 millimeter, and normally you will have a lot of problems with Wärtsilä cylinder heads. So here you can see we do a regular testing before we send it out to the client. We test the thickness, wall thickness, and if it is less than 16 millimeter, this is for a RTA 52, then we do a complete reconditioning job on this. These are cylinder heads which have been completed, after reconditioning, and this is before dispatch on the ships. So you can see this one. Basically, these are related here. You can see the problem before and after. These are all related here. Let me take you to another slide, some more photographs. So this is RTA 82, that's 820 millimeter bore. That's the biggest we could handle. Actually, when it comes to MAN MC series, max we can handle is 70 MC because of the size of the cylinder head. But for a Wärtsilä RTA 82, we could just manage by doing a lot of modification on a machine. So again, you will see before and after photographs. This is, you can see here. You can see when it came, the O-ring grooves were damaged. The ship staff tried they did a lot of jugglery to remove the jackets. The jacket was stuck. This is the jacket which was cracked. There were no spares, so we repaired the jacket for them. This is basically exhaust valve seat which was jammed inside. This is the seat you can see here. which was jammed inside here. The below row is basically the jobs which were finished and before delivery to the client. So this is how you can see before and after photographs. And even we managed to repair the jackets. Normally cracked jackets and jackets in two pieces are difficult to repair. But if you don't have spares and the ship has to move, then you have to do something. So we managed to repair and the vessel sailed out. So that was good. So the client was very happy with that. So this is also before and after. You can see the seat on top and after restoration on the bottom side. So bore cooling is what we spoke about, and you can see here the bores which are badly choked. You can see a lot of rust inside and a lot of scaling inside. You can the second photograph here, you can see here people have tried to weld. Obviously, I mean, when you're on the ship and you need to run the engine, you need to do something. So people have tried to do weld repairs, you know, and try to do something to run the engines, but obviously they don't usually work. On the right side, you'll see a before and after report. This is what we normally give to our clients after the job is done. So he can keep a trail of it in his records. Coming to the next one is 4-stroke cylinder heads. We get a lot of 4-stroke cylinder heads. We do about 150 to 200 4-stroke cylinder heads. And the biggest problem we have is point number 1, erosion in way of exhaust seat pockets. And this is normally due to insufficient chemical dosing or bad cooling water. Then we have liner seating area burnt out, damaged or substantially broken due to overlapping, cracks and leaks in the gas passage. We have seen this cracks in gas passages normally in coastal vessels. No one knows what the reason is. We've had sister vessels where on one vessel there is no problem as such, but on the other vessel there is a peculiar problem where all the 3 engines are having the same problem. So either it's something to do with the cooling system or maybe material failure. Then you have centerline problem we've seen for seats and valve guides. Very big problem, and this is normally when workshops or when ship staff don't take due diligence and due care for maintaining the center line. And if you don't have that, then you will have cracked valve seats and broken stems, which can do further damage to your turbochargers and other machinery. Then you have cracks in combustion area between the valve seat pockets. This is again a very common problem for 4-stroke cylinder heads, especially cast iron ones. The gap between the valve pockets and valve seats is very less. And if you have stress in one, if you have basically hammering in one, the other pocket gets affected. And the easiest way to give away is a crack in between the 2 pockets. Then you have choked water passages. Again, this is related to chemical dosing and good water. Fuel oil pockets, seating eroded and other damages. I would attribute this again to insufficient chemical dosing and basically over tightening of fuel valves. Water connection holes eroded and seating surfaces damaged. damaged threading or threading enlarged due to over tightening. Very common in, you will see that in cast iron heads. Various seating areas damaged in the cylinder head. So we get heads like this. I mean, what you're seeing here is a very good head. We've had heads worse than this, where you had a lot of erosions. And this is basically overheating inside the combustion area, or maybe a broken spindle or something which is damaging the combustion area of the cylinder head. This is gas passage, and you can see, I mean, there are leaks here. Again, you have erosion of material. And this is after repairs. This is after repairs, after we've repaired them. So cast iron welding is not only difficult, but it needs a lot of patience and perseverance. It's not like your normal welding. So here you have to heat the job properly. You have to take a lot of care when you're doing it. And at the end, I mean, you are definitely going to get good results if you follow a good procedure. Here people have tried to do some welding and, you know, to repair. This is what we received from the ship. So this is liner seating area surface which gets damaged. This is the liner seating area surface. This gets damaged. Again, this could be improper tightening of the cylinder heads. So that is what causes a lot of leakage, and then you will have erosion on the seating surfaces. We do build up of pockets, but normally we don't like to do this kind of a job. But if the client insists that he wants to go back to standards, then we have to do it. Normally, we prefer to do a oversizing of the pockets and then fit an oversized seat. That way you don't put heat onto the cylinder head. And oversizing seats, I mean, you do it 0.5, 1 millimeter, 1.5. And we make these seats. We make them in-house, and they're good forged material. They're the same method and the same process what the OEMs use. So there is no quality discrepancy when it comes to manufacture of the seats. But if you try to weld the seats, then you can see the photograph on the side. This is after we welded them. They turn out to be pretty good, but again, they are welded, and I personally, I don't like to do that unless it's necessary. We had a case where there was a very old dredger which was using this engine, a European-made engine. The engine manufacturer has stopped production. So the dredger had come to India. We got all the cylinder head for repairs. There was no spare cylinder head. And one of the cylinder heads had a very deep crack. So we did manage to rectify this cylinder head. And I think it's been over 2 years. It is still under operation. So this was something, I mean, the client was quite happy that he could restore the engine back to normal. And, you know, it's still in working condition. This is normal pressure testing of cylinder heads. We normally pressure test the cylinder heads to 8 bars, 10 bars. We normally try to take it to 10 bars just for our safety. So the cylinder head that I was talking about, previous one is this one. So you can see here, after build up. So there were about, I think, if I'm not mistaken, 12 cylinder heads. So you can see the cracks here. You can see the cracks here. And this is after repair. This is basically, this is another cylinder head, but yes, this is after repairs. So on the left hand side, you will see different types of repairs that we do. The first one was the combustion area which was damaged. So that is being rectified here. So here, second one here you can see is, this is how we received from the ship. Maybe they tried to put the seat and tried to punch it all around so that the seat doesn't come out. So anyway, we did a rebore and we fitted the new seats inside. Again, here you have problems of seating, liner seating area, and that's what was rectified. And the last one here is, you can see they had problems on the combustion area. And this is after rectification on the crack check. So we normally use crisp marine machines, which are very good for pockets, but it depends, because these machines are okay only for light work. For normal bore work or whatever, then we have to use conventional machines. Then we have cast iron cylinder heads. I mean, these are basically for compressors. So get quite a few, because when you do over tightening, or they start leaking from one side, then basically we take them to task and so we take them to task and basically do all the repair work on them. And this is after machining, and this is the complete body of the cylinder head. Normal problems that we've been facing are generally erosion on the combustion surface and threading damages. Few cracks, you normally get cracks here, in the bridges, you get cracks here. So that also we did quite a few repairs. Otherwise, you will have threading problems here. Go on to my next slide now. We go over to cylinder cover jackets. So jackets nowadays, everyone is using the sliding jackets. Earlier the jackets were welded on, and I don't know why a lot of people changed over, a lot of the OEMs changed over from the welded jackets to the sliding type jackets. These are the sliding type jackets. And welded was basically, you see the cylinder head here. Instead of the jacket is completely welded from both sides. So you cannot do anything on board the ship. You have to send it to a workshop, even for cleaning it, for opening it. If the jacket gets wasted, then you have to, cut it open and put a new one. Personally, I feel those jackets were very good, much better than these jackets, because these jackets have not anyhow eased up the situation for the shipwearers or for the engineer on board. You can't do much about it. You have a lot of problems with cracking. You have a lot of problems with erosion here. A lot of erosion problems here. And the O-ring doesn't set, and you have leakages from O-rings there. So there was a reason why the OEMs have shifted to this, but if you ask me, it's more of a mess. So here we do a lot of work on jackets. I mean, again, jackets we do more than 120, 150 in a year, different types of jackets, different versions, different bore sizes that we get. So here I think you can see in this one is a 42 MC. These are the cylinder heads, these are jackets for them, and here you see the exhaust valve cage. This looks like a 60 MC jacket to me. And this one is a crack jacket. Again, basically the owner was doing the coastal run. He did not have a spare jacket, so he requested us if we could weld it. So we did the job, and it did run till he got the new spares. Here you can see all the jackets on the right hand side, basically jackets which are welded, machined, and ready for dispatch. Then we'll go on to connecting rods or piston rods. So two-stroke piston rods, basically ovalating the rods, not much one can do other than you reduce the size and go on to the next undersize. You can also do chrome plating on the rods and bring them to size. That's another way of doing it. Then you have dimensional reduction way down in the rods. That's what we spoke about, ovality and dimensional reduction. O-ring grooves damage, blue ball holes getting choked. Rare, but yes, we have seen one or two. Jammed piston rods in piston crown and skirt, quite a lot. We get a lot of these jobs. Basically, they are not able to open them or remove them on board the vessel, so we have to use a lot of heat. We have to gouge them out sometimes. You have to use presses to get them out. So here are a few examples. This was a recent job that we did where we opened up. You can see this is a UAC engine and it's burnt through. And the reason for this burning is only one, that's fuel injection or fuel spray. So it has gone and it has basically burnt out the piston crown, and it has welded the piston crown to the piston rod hub here. You can see on this part here. This is of a 60 MC piston rod and piston crown. You can see the damages due to running the, piston crown. I mean, obviously you can't stop the engine or you cannot do anything. So by the time it has landed to the workshop, there's a lot of damage done. We come to 4-stroke connecting rods. So here you have 5 major problems, basically 4 actually. There's ovality in the big end bore. That's the biggest problem that we are facing, that we get in a workshop. Bushes worn down or damaged, threadings damaged, and blue ball holes choked. Quite a lot of blue ball holes choked in this one. The biggest problem that we face is ovality in the big end bores. And you can see here, after they've been recon, you can see the bores here. So these were for an export order that we had to. We bought these from Alang. Basically, there was no material left, available. So we bought these from Alang. We reconditioned them and sent it to a European client. And this photograph on the right is basically the bushes that get worn off. and these are press fit. So little difficult to do on board, but it's not such a big challenge. I mean, it can be done on board. A lot of people keep talking about bent rods. We have never found any bent rod as yet, unless obviously there has been an accident and it has damaged. Otherwise, we have till date, we've done so many rods, but never found any bent rod as yet. Liners. So for four-stroke liners, normally you have ovality problems, burnt out seating areas of cylinder heads, and O-ring grooves damaged. It's quite straight and simple. We do honing on these. Enlarges the size a bit, but obviously gives much better lubrication and much better combustion once this is done. And burnt out seating areas, normally these areas, they get burnt out. So if it's a very minor one and less than 0.1, then we just grind it. If more, then we have to do a build up and then machine it to size. Two-stroke liners, no one bends them. No one does any repairs. But we've had cases where the vessel is stuck, liners are not available. Carting the liners or air freighting the liners is way too expensive. And we've gone ahead with the request of the clients to do it. I mean, you can see the cracks. You can see how they are. And this is basically after welding. But these will work. I mean, it's not that they will never work. These will work, but it all depends on how you use them, because you need to lower the power in that cylinder. You need to put more lubrication. They will take you to the next port of call, or at least it'll save your skin for some time. Not a good way of doing it, but then with low sulfur fuels nowadays, there are a lot of challenges operators are facing. It's beyond their means to, keep putting liners on board. Liners availability has become a big challenge nowadays. We have shipped 2 liners of 50 MC from China to Panama. The cost of the air freight was more than the cost of the liners. But the vessel was stuck there, they could not move, and they had to get the liners in. So challenges are there, but if someone wants to take a risk, then they do it, and we cooperate as much as we can. Pistons. So for two-stroke pistons, you have worn down grooves, eroded piston crown top. Very often you will find the piston crown is eroded, and nowadays we finding this now after changing over to low sulfur fuels. We're getting this problem more and more. Burnt out pistons, damaged threadings of piston rod and skirt, and lifting holes. So you can see here absolutely thinned down, webs here. This web you can see is absolutely thinned down here. And that too, it's between the number 3 and number 4. Very surprising, So I think number 1 and 2 piston rings must have broken, and the total load must have come on the 3rd piston ring, and that's how this has got damaged. Complete webbing cracked. This is basically overheating. Again, your number 1 piston ring must have gone damaged. The whole load must have come on this one. So this one on the bottom, you will see lifting holes. damaged and cracked. Just looks like a piece from the ship side. No one must have looked at it for years, and then eventually they sent it to our workshop. You can see this is all rusted here. When we got this, there was metal peeling off. The rust was flaking off. So these are a few jobs which we have done, the after, before and after photographs. Two-stroke piston skirts. Earlier, rubbing band was used a lot. Nowadays, they have done away with the rubbing band, and very few models now are with these rubbing bands. Otherwise, you are straight away having cast iron skirts. They're very cheap. When they're worn out, you just throw and use new skirts. So when you see a skirt, people think that it's good, but a lot of people don't measure it. And skirt is supposed to be a consumable. You are actually supposed to throw away that skirt and use a new skirt. This skirt is a guiding skirt, and people don't pay a lot of attention to this. A lot of good operators still send us for repairs, So you can see here where we have changed over the rubbing band. We put new rubbing bands here. And brought it to size, but very few operators even know what is the reason of a skirt and a rubbing band. And if people actually use new skirts, you will have less problems on your pistons and piston rings, because this skirt is actually what is centering your piston. You can see a damaged skirt here. So, not much that we could do because it's on the bottom side, and its operational areas were rectified and given to the client. So rubbing band wearing out or missing, that's one major thing that we've received. Cracks in skirt or in the bolting down bolt holes. So the second point is mostly related to RTA skirts, where you have a different construction and you normally have a lot of cracks in those bolt holes. Four-stroke pistons, not much that we do. We often get jobs for grooves worn down, and I always recommend the people to go for oversized rings rather than doing any repair to it. A lot of makers give oversized piston rings, so we can grind them down to the required size and give it to them. We have done cladding on these piston ring grooves also. Works well. They depends what kind of piston material is, the MOC is, and it works well. We've not had complaints regarding that. But again, rather than putting heat onto the piston crowns for the four-stroke, it is better that people grind them and use oversized rings. Second point is removal of scuffing marks from piston ODs. Quite a lot we see damages on the piston ODs. Damage in circlip grooves for holding piston pins. Damage in gudgeon pin bore. And in the Wärtsilä pistons, you have damage in the chrome plating between the head and the piston body. Watchilla has got a very good design for these pistons, and they really work well. They have basically kind of a chrome plating, on these surfaces. So where they match, and then you top tighten them, and it has proved to be a very good design. Gudgeon pin bores, we don't recommend that anything be done. Better to scrap them off. No point in repair, reconditioning them. Next is exhaust valve spindles and seats and cages. So here basically for two-stroke exhaust valve spindles, I mean, you have eroded material from the lid area, damage in the lid area, or a normal wear down in the lid area, eroded bottom of the spindle or cracked in the bottom side or OD, O-ring grooves eroded on the seats or on the cages. Basically, this leads to a lot of leakages and you have water pouring out from the engines. Dimensional irregularities due to improper drawings. Gas passage area in the cages thinned down or cracked. Threading damaged in the cages on the exhaust and water flanges and spindle guide review. So let me start with the worst one first. You can see this erosion here. There's only one and one reason: fuel impingement and fuel injector problem. You can see another one here. There's a hole through and through right here. This is heavily eroded. You can see the spindle which is heavily eroded here. This is bottom side of the spindles. So we go as per the OEM's recommendations. They have given recommendations. You can go bore wise, how much max you can go. And this you can see a chrome plating damage. You can see her problem on the chrome plating here. On the top side, the shining ones are the ones which are completed, reconditioned and ready to be sent to the clients. So these are the O-ring grooves which you need to look into. This is a UEC, so there is one groove here and then there is one groove here, which you can't see in the photograph. So there's one O-ring coming here and one O-ring here. So they normally get damaged. I think I have in the future slide, no, for the slides I have more examples of this. I can show you. So here is another photograph you can see of O-ring the grooves damage. So we build it up here. You can see it here. We do a build up here and then we remachine the grooves. That is the only best way of doing it. I mean, part repair doesn't work. This is a RTA 52 cage, and you can see the cracks here. The cracks were quite deep. So we did the repairs for them. This is a standard report on the left-hand side that we give it to all our clients before and after. But we normally do a normally we do a number punching on all our products, all our components. So we can actually track our components when they're coming back to us. And what we've seen is the components which we receive back, even after 2 years or 3 years, they are much, much better than the components which are unnumbered or from other workshops. I mean, we follow a lot of procedures and use the best of the materials. We do not compromise on our welding materials, because if your bonding is good, if your procedures are good, these components will last a long time. You can see here a distinct example, basically. The right one is basically, this is a spindle which has come back to us. I don't remember, but I think it was after 2 years. And there must be a shelf life also of 6 months. So I can say it has run in the engine for 1.5 years or whatever. Very good performance. This is I think UEC 60 spindle ready for delivery. And on the back side, you can see, I think this is 70 MC spindle.
Sanjeev sir, may I come in? Last 5 minutes, please.
Okay, so I'll have to rush. So this is the biggest spindle that we have done. That's a 98 MC. What is there in the Indian market, mostly on the container vessels. We do manufacture spindles and seats and cages. You can see here, these have been manufactured by us and we refit it and we give it to them. Cast iron casings. So you get a lot of cracks in the casings, sealing surfaces damage, threadings damage, thinning down of casings, and we also make a lot of casings, new casings. So here you can see a reefer compressor with damaged casing. The webbing was damaged here, and I think one of the foot somewhere was broken. Jammed and stuck components. A lot of pumps we receive which have got jammed impellers inside. We've spoken about this. Seats that get jammed inside, then piston crown and piston rods, getting stuck inside. In situ grinding of crankshafts. So we can undersize them, we can polish them in place. You don't have to dismantle the engine. We send our people on the ship and we do this work. Pump casings, center line, normally we find out wear line of line bushes, wear down of bearings, worn down eroded bearing pockets, thin down casings, eroded mechanical seal area. So these are the various pump jobs that we keep doing. Let me go to the next slide. So this is before and after, where these are the huge pump casings that we receive. I mean, you put them on the machine and centerline them. It's no point just putting new bearings if you don't centerline them. This is also a huge pump that we received from a vessel. You can see before after reports. More examples of pumps, casings, how we receive and how we centerline them, how we do them. We also use epoxy instead of normal paint, and we do color coding. So when you're down in line in service, you come to know how much is the wear down. Gear pumps. that's where we specialize in. A lot of gear pumps we do. Center line out, wear down of line bushes, damaged casings, damaged faces, relief valve pockets damaged. So this was a very interesting case that came to us. This vessel was a RTA 58, and the main lube oil pump was damaged. This was built in East Europe, and the company was closed down. Now they could not get a pump which could fit in the engine room with such, compact pump. You can see the pump here. I mean, it's so compact. The other pumps, they could not fit because they had to change a lot of pipelines. And the owner was so fed up, he wanted to sell off the ship. So we made these casings, we bought them to size, and we delivered to the vessel. That was a good, interesting job. The owner was quite happy with us for this. You can see here, we are putting the screws in the casings. Various pump shafts, I mean, we get a lot of pump shafts to be made. Gear pumps and screws. Again, here there's a story of a vessel which was stuck in Mumbai anchorage for a month because the delivery period of this gear pump was almost 3 months. So we repaired this shaft and the pump and gave it to them. Took us about 2 to 3 days, but the client was quite happy. Pump impellers, we remanufacture impellers. We have a lot of patterns with us and we make it as per the client's specifications. These are a lot of other components that we do. You can see bearings. These are line bearings here. Before, after. Fuel injectors. Quite a lot of fuel injectors come to us. The surface here gets damaged. This is a rotary valve for the starting engine. These are air cylinders, electric motors. This is a shaft, conveyor shaft for a cement carrier vessel. And here you are seeing a crane. I mean, this is for a FPSO. These are roller turrets which are fitted on the forward of the ship. So with this, I finish my presentation and thank you for giving us an opportunity to speak about this subject. Thank you.
Thank you, Mehra sir, and thank you, Raizada sir. It was a real good presentation for any marine engineer. Diesel engine is very close to heart, and practically, except probably the crankcase, all components of the diesel engine have been comprehensively covered. There is a good success story about the repairs of the lube oil pump. Repairs in situ of crankshaft, grinding, etc. are quite significant because they reduce cost as well as improve, the time of repairs. He has also highlighted the need to follow SOPs and particularly to avoid, like fuel impingements, etc. If we follow SOPs, if we follow clean fuel and good engineering practices, probably these defects can be minimized. So thank you very much, sir. It was a real good presentation. And for me, it was quite informative. Thank you very much. Now we come to the next presentation by our guest of honor. Here I am at loss whether I should address him Professor Avikshit or Dr. Avikshit or as my friend Commander Avikshit. I will choose the last option. We have put on uniform and I think to him also this identity will be very close to his heart. So, dear Avikshit, it's a great pleasure for me to introduce you. He has done his PhD. He is a dean, presently is a dean in management and commerce at Rayat Bahara University near Chandigarh. He has 37 years of exhaustive experience, a subject matter expert on project and program management, industrial operations, business development, and alliance management. Apart from management and engineering, he has a deep interest in studying human behavior, vagabonding, and exploring the world. He is a much sought specialist for success in life coaching, leadership, career counseling, and mentorship. He was commissioned in the Indian Navy in 1984 after he graduated from Punjab College of Engineering, Chandigarh. He has completed his MTech from IIT Powai. He has done MA in Applied Psychology from Annamalai University and a management course from MDI Gurgaon. His experience of the service in the Navy spanned for 23 years. He is a submariner who had served on Russian and German origin submarines. He has also worked at submarine headquarters and naval headquarters. He was also a teaching faculty at Naval College of Engineering. He had served in Pipavav shipyard. Subsequently, he was lucky to have some great masters and mentors who have honed his skills, which helped him to become Chief Operating Officer at a private sector. He is author of a book, Leadership Behavior and Employees Morale. But this is all official introduction. Avikshit, if you permit me, I will also like to throw light on your probably hidden side of life. He is a great astrologer. Those who wish to consult him, please contact him. With this, over to Avikshit for your lecture. I am eagerly awaiting your inputs.
Dr. Abhishek, sorry, Patil, request to all participants who are having any query, they can put your their question into question and answer box. Thank you.
Okay, may I, sir?
Yes, Avikshit.
Dr. Abhishek.
Yeah. Thank you so much, Talwalkar sir. Your such a lavish kind words have taken me back to 1984-85, when we used to sit in the corridors of INS Shivaji with Bhandarkar sir roaming around there. And I mean, I am really overwhelmed, and I got more overwhelmed after the last presentation, sir. You know, sir, like you have told the august audience, that I am basically a marine engineer, then went in a private sector in the shipbuilding. Now I am with a management school. You know, when I was telling my students that there is a webinar today, I mean, just that was around 2 weeks ago, my heart is always of an engineer. But then I realized over the period of time, I do not know when I shifted to the management, sir. So they said, I told them Commodore Talwalkar's profile, Captain Siva Patnaik's profile. They said, sir, we are going to attend this, and in any case, kindly get us the presentation. I know that they will be telling the things at a very high level. So you kindly restrict yourself to very basic. Now, even to get to the basic, then I did not know where to stop and from where to start, because basic itself has got such a large spectrum. Engineering, then mechanical engineering, then marine engineering, then the auxiliaries and the engine. But one thing is very sure, the last presentation, I will be taking honorary classes with my engineering students at my engineering college to show them how the components look like, how the components are about the maintenance management per se. Having said this, I will be, my presentation or talk is very small. I'll be covering some very basics and some core things. Say for example, when I say core things, it means, first of all, whenever I speak to my students and others, I ask them that, do you know the difference between engineering and technology? So, and you trust me, most of the time, they are at a loss to answer, because Somebody gives BTech, somebody gives BE, somebody is BSc engineering, somebody is diploma in. You know, the technology everybody knows or everybody can buy. If you have a money and you have a knowledge what to buy, there are enough expertise in buying what to buy in accordance with our own requirement or what to use in accordance with our own requirement. Whether I want a Samsung or I want iPhone, that is about a technology. When this technology, to reach that technology, it is the engineering that makes a difference. How to reach there? Technology is one. And that is probably the most interesting part of any product. The product can be engine, product can be anything, product can be control system. And the difference between science and engineering and technology is that science has only one solution, one law. This is a law. Every action will have equal and opposite reaction. Engineering will have so many solutions. To select the best solution is the key. That is where the difference will lie in the different, you can say, in the different yards or different manufacturing units. So without engineering, the technology is not complete. Now, speaking about engineering, we have to have a skill and a leadership. So the skill is about a welder who can do 6G welding, X-ray welding. Skill is about a welder who just has to do 1G, 2G, 1F, 2F, and all that, like, you know, the monotonous ones. About the leadership, unless and until it is combined with the above three components, the completeness of any technology, engineering or skill is not possible. The product that we are giving to society, to our mariners, to the users or the maintainers is not complete. I will start my presentation only, I just want to narrate a very small story. When I joined a private sector from Navy, the promoters, they wanted some neutral persons. Neutral persons say Avikshit. Avikshit knows how to run a ship. Avikshit does not know how to build a ship. So they hired some ex-IHI. IHI is a Japanese shipyard. They hired some experts there, some mentors and masters. And every budding executive, I was taken in there, was allotted one mentor. My mentor was Togo-san. The model was like this. In the first year, he's a mentor and a boss. Second year, you are the boss, you take over and you start producing your own work, and he's a mentor. He remains a mentor. Third year, he sees if you are okay, he leaves. I think that was very, very good model to learn, to imbibe, and to see what the leadership is all about. And only one shikayat. He loved India. He loved Indian foods. He loved Indian young engineers. He used to tell me, Avi-san, your older generation. I used to tell him, we are also old. He said, yeah, you are in the middle. They don't listen. We had some very senior people from GRSC and other places. He said that you always resort to Jugaad. I told him, no, Togo-san, we don't resort to Jugaad. We have our own systems. Our yards have produced so many ships, so many warships. He said, okay, you can do much better if you proceed the things in a 1, 2, 3, 4, 5 steps, like, so and so way. When we were, the first product from that shipyard were Panamax, 2 Panamax bulk carriers. There was no yardstick, there was no benchmark in India. We had the Japanese benchmark. He told me, okay, you give me any number. How many Indians will perform equivalent to one Japanese? I really got slightly annoyed and ridiculed that what question is he asking, Togo-san? Togo-san, what do you mean? He said, see, you are doing this thing for the first time. Your yard is new. Your machines are new. Your everything and your jobs are getting trained. So let's assume some figure. I told him, okay, you assume some figure, one Japanese equivalent to so many Indians. He said, okay, after 2 Panamaxes, after 2 years, when we analyze the results, we were way off. Whatever figure I quoted, we assumed, not quoted, we assumed, we were 3 times wrong. It means if I said that one Japanese equivalent to will produce equivalent to X Indians, one Japanese was producing equivalent to 4 X Indians. And that was one motivation which gave me, that was one incident which gave me motivation to do PhD, because I spoke this incident to one of a very senior professor who was a vice chancellor. He told me it's an excellent topic for result. When the whole thing, after 4 years, 5 years, 4 years, I completed my PhD, then I realized the problem was with the leadership. Because I mean, that all that we will discuss sometimes later. But today I want to first tell, basically I am directing this particular presentation at a very, very young crowd, which eventually I will also show to my students, that when we say technology, what first of all, any latest technology will remain same all over the world, whether it is engine, whether it is communication, whether it is control system in the aircraft and in the submarine. Raytheon Marine would give control system. The technology remains the same, only its application that would differ. So it's a very basic definitions I am planning to give, because anybody searching on the Google will say, okay, which are the new technologies in shipbuilding? Which are the new technologies in aircraft making? Which are the new technologies in car building? Which are the new technologies any building? So they will be covered under this, say, for example, 3D printing. Many people do not know. And especially my management students do not know. There is a mix of management and engineers in University School of Management Studies. So when my teachers speak to them, they should come at par. They should know what is robotics. They should know what is VR, AR, virtual and augmented reality. And of course, as I go along, I'll be speaking about everything which I am showing on a screen, about LNG, of course, because CNG everybody knows, and what is fuel optimization. Because once our people, they know the basics, then it is easier for them to imbibe. That is, imbibation is my is my focus today. That what it is. So I am addressing, like Togo-san would always say, young engineers. I'll say any youngster who is sitting here, all my panel colleagues, they're highly learned people. They know much beyond all this. I'm very sure when Captain Patnaik will attempt, everybody will have a kind of a knowledge and a view which would be par excellence and not known to anyone. What I am showing, that to understand that what he is going to show, though I have not seen, but I know him. He is been my senior colleague and my my boss, whatever. So I know his level. I will also learn a thing or two from him. Why a thing or two? A lot of things. So the 3D printing is to create a real object from 3D models. Now, how the 3D models are made? They will be made by some design software, CAD, say. Now, those 3D printing will create, now it is creating small components, the complex geometric shapes. So though we call it a 3D printer, when somebody told me the 3D printer, I thought it would be something like, the laser printer and an inkjet printer, which is lying in our offices. But when I came to know what the 3D printing is all about, you make a 3-dimensional components, a small structures. This 3D printing is going to create a 4th industrial revolution. We will all see in our time to come. So this is going to be the basis of manufacturing, right from the design. There is a model, three-dimensional model. There is an interface. The 3D printing is going on. Then there is a component. We all know what is a robot. We all know robot is a kind of an arm or a leg or a whatever standalone or a mix of some software controlled equipment which will do some job for you. Now, what job for you? It can do welding on the curved area of your ships. It can bring a components from one place to another in a fixed amount of time. It can change tools on your machines. And as the days are passing by, this robotics is not a new term. It is an old term. But on everyday basis, its meaning and its capabilities, they keep on changing. Now, there is something called flexible manufacturing system. So that will be based on more and more versatile robots. Now, in the shipbuilding, there are advances like, with the robotic facility, you can do the cleaning of hulls, inspection of pipes. So many automated processes. In my yard, we have all the robotic welding machines, and the way they would move in the channels, in the rails, on the curved areas, on the flat areas, it used to be a treat to watch. It used to be an art just to see how the beautiful weld is taking place over 30 meters, over you can say by 30 meters on the horizontal line, even up to 50 meters. So the long monotonous tasks which the manpower is doing, man gets bored, man's hand is not steady. Yes, you can have a lot of automated system. When it is coupled with the robotics, the whole meaning change. Nowadays, there are modern sensors between the operator and the robo. Robo is as intelligent as a man. This man is controlling more than one machine. That machine is a robo. I mean, needless to say, what kind of efficiency and what is a kind of quality that is possible to achieve with the advancement in robotics. This one is about the virtual reality. Now, at this particular time, we are virtual reality and augmented reality. It is being used for training and part positioning. If I want to tell you in a very simple form, augmented, what is augmented? It means enhanced. It is connected with the real world with the virtual. What is virtual? Which is not there, but it is giving you a feel it is there. Data is extracted from a virtual system, and with the augmented reality, it places where it is required to be. That's all. That's all. Other applications you can see on, my right-hand side of the screen. It is highly useful for production and maintenance. This is going to revolutionize. And I'm very sure, Mishra sir, the way he shows, the way he showed the kind of a maintenance they are talking about, I'm very sure they are very, very soon, all the forward-looking maintainers of this country, they are going to imbibe this before many other advanced countries also. Now, this is interesting. So very interesting. Liquefied your natural gases, environment friendly, everybody knows. reduces emission by 92% and 20 to 25% vis-a-vis diesel engine. That is about NOx. And there are major players, Mitsubishi, Wärtsilä, Rolls-Royce, MAN. I mean, everybody has to develop engines which are, the dependence from diesel, from the petroleum, from this diesel product, it has to be weaned away in the times to come, because more and more of green energy, more and more of efficiency, more and more of advancement and harnessing the capability of engine, which is being done on everyday basis, and that is the future. And IMO also, they have put such a big restriction that we have no choice but to turn to this. I think everybody knows there is a huge agreement between India and USA to transport LNG from there to India. The challenge was to make those LNG carriers, because government of India, they put a restriction that at least some number, they should be built in this country, and rightly so. And that fuel is going to be a much cheaper fuel. So next in line is, it's about cladding, Cladding, what is cladding? Dhakna, coat karna. No, here it is about, I'm talking about stainless steel or stainless steel piston tools. Great. It's very, how do I say? It's got ability. With the ability to combine alloys, we can develop liners, okay, with this technology. It's got a shortened supply chain, because they'll be easy to carry, and there will not be any resistance or damage during the transportation. This again, this security. Now, when we talk about the modern technologies, it is the technologies will remain same even for warship or for merchant vessels. Its application, its advancement, and its particular use will differ from platform to platform. This right now, we all know there is a big integration all over through the internet, through the cyberspace, and cyberspace has been invaded either ethically or non-ethically. Just to tell you, just 5 days ago, I got some scamsters call, and they are demanding some money, trying to blackmail you. Nothing is safe. Your mobile is not safe. Your laptop is not safe. Your vessels are not safe unless and until we take proper precautions. No, how do we take proper precaution? We take this. We have to integrate this security system against the cyber attack with a ship's system. After all, the ship's system, they are based on sensors. Sensor will pick up certain value. Value can be of a freshwater temperature, or value can be your communication ability with the shore, or the sensor from where you are transmitting. It can always pick up some sensitive information. So this, the real-time data from the ship sensor and land managers, it has to be very, very secure. Fuel optimization system. It's beautiful. My student asked this, sir, you are talking about this LNG, CNG, and you also say that ships are 20 years old, 15 years old. How will they, what do you think that they will keep on incurring cost? How the ship owner will ensure that he is not running into losses, even with the older ships? That was a very good question. Since I knew the answer, so it is in front of you on the screen. Like this system, the system will track, measure, and display the behavior of what your fuel is doing. And those system monitors, they give you recommendation for optimizing and reduction of emission by say 12%. For maximum diesel, they say that this particular system may be better than the liquefied natural gases. And if we need to use this, it should be installed at the time of shipbuilding so that the proper engineering is the base of this. So, yeah, installation is also provided on ships at sea. So that's, I mean, everybody knows this, my senior colleagues. This is beautiful. Now, this material. Now, this particular material is being used in the aircraft industry already, though not very extensively. It is a sheet, you can say. It is called carbon nanotubes. It is 50,000 times thinner than here. These are sheets. So one tenth of a load of a steel, but 5,000 times stronger. Needless to say, what will happen to the weight of the ship? We will have much lighter and the stronger vessels. It conducts electricity in a very efficient fashion, like it conducts in silicon, and it scatter heats like a steel. That's from the net I got this sentence. And wherever it is this material is being used at a cover, it is also fire resistant, better fuel efficiency, safety. I mean, you see, when 5 to 10 years down the line, the use of this material will become more extensive. We can see where we will be. I do not know why they call it electrical propulsion. I tell you, as a submariner, they say gas turbine will generate power, and the power will in turn run motors. Fair enough. When I was a young lieutenant, when I joined Navy in 1984-85, after completion of my training, I joined submarines, Foxtrot submarines. That's the time diesel engine used to, they were the prime movers for a power, and the electric motors will directly run the submarine. Nowadays, the batteries are charged first, then electric motor is run through those batteries. But here, there used to be arrangement with the clutches. Beautiful. Either you can charge battery or you can have a direct propulsion. So the electric propulsion is not something new. The prime mover, the gas turbine concept, this will be used in in the future electric propulsion. It will reduction of weight, volume, less overall noise, but nobody is talking about expense. It's going to be very, very expensive. It's a very expensive. There is always a discussion between electrical and engineers. Somehow the name has come to electrical propulsion. Fair enough. The propulsion is propulsion. Howsoever you may do it, but that is a technology of the future. That is much more efficient, much more cleaner. AI, I don't have to say. Artificial intelligence system. Your machines will work with that. Your maintenance management will control with the artificial intelligence system. That's all I wish to say about it. Now, okay, IoT. This is a term which I learned very recently, just a couple of years ago. Internet of Things. Now, and this course is being offered by maximum students. Lot of books are coming on this Internet of Things. It is a trend not only in shipping, everywhere. Like I said, Here, the physical devices or sensors, okay, they share the data with website. मोटे तौर पे यही. No, you can use this information for anything, for design, for manufacturing, for planning, the way you wish. IoT is here to stay. That's the bottom line. Now, this is very dear to me. When, like, you know, I am an engineer. About the ship's design and about the ship's construction, I never knew, like I already told you in the beginning. And immediately we were exposed to the technology that the block has to be fully fitted. How? There the role of design comes into play. You are going to cut steel on the day of steel cutting. The first square that you cut out of that steel plate, 5 in number pipes are going to go through that. Fuel pipe, water pipe, this pipe, that pipe. Now, how will you conceive that where this part is going to get fitted, how the pipe will go inside? So the outfitting and design. Okay, I'll say the design of blocks, the pre-outfitted blocks. Now, in accordance with your shipyards and ship lifting capacity, the place where I worked, there the block lifting capacity was 1,200 tons. 2 Goliath cranes of 600 ton each, 150 meters span, a hook height of 75 meters. One Goliath is recently in a storm it fell down, but that is a capability. You see, now these are the actual design, you can say, models which were used to create. Now, if you have this kind of a facility in front of you, why? There is no reason why you will not have very, very efficient production mechanisms, of a very, very efficient production capability, very, very rare rework, very efficient production mechanisms. So some software resources which everybody I think knows. ये मेरे सामने थे, so I thought I must put them on a screen. I think Kedwin people may not be aware. Kedwin is a master software from Korea for basically just to reduce your scrap component. This software, it gives you the maximum output from a plate of steel. That's it. So others, they are very popular. They are, I think, all the yards they are using. Then it is about the infrastructure. What infrastructure you want to put in? The things are available. Like I told you, everything is available. Then it depends on the decision makers. How to, and what to buy, how much to buy. So for example, like I told you, here, this one is a completed block in a air-conditioned blasting and painting chamber. Complete. Here, this particular engine is, no, this is a block. I will show you one engine also. I've got that picture. And before the dry dock, this is a Panamax being constructed in the dry dock. And on my left-hand side, there is a pre-erection berth where the blocks are already being joined to match the capacity of your cranes. That is all about engineering and planning, your production planning. And I want to make a very, you can say, bold statement here that none of the so-called these ERP systems is successful in production planning. They are very good in store and supply chain and all that, but on production planning, till now, right from Mars to SAP and all that, there is no good production planning system. You can see the fully outfitted block here. Now this process I show to everyone because it's very dear to me. It is called line heating. Line heating, only with the heating and cooling, you get the complex curved shapes. I could not get a picture of much more complex curved shape, but this is the one I'm showing it to you. When Japanese trained us in this particular process, they trained the manpower. All the 24 people who were trained to do this, they were posted by the sister shipyard, some other shipyard, competitor shipyard. They could not work for more than 7 days with the same manpower because ultimately it was designed that where to draw a line from where you are going to heat and cool. So that is about engineering. So here, what is, yes, this is another good one. Now this engine, this came from Korea, 350 ton, if I'm not mistaken. Originally, after FATs, after factory acceptance trials, this would have been disassembled in 3 pieces, then brought to India to be installed on board a ship. But this complete engine, it came by sea with a barge lifted by Goliath crane, straightway put in a block. Complete engine. And this was the only equipment: engine, generator, and boiler. These 3 items were put in from outside. Rest everything was already put in the mock model in the workshop. If you see here, this was all pumps, motors, everything was assembled outside, then shifted in the block. That is the beauty of modular ship construction, where engineering is. This is one picture of completely pre-outfitted block, 59 meters long, OSV ka tha ye, and it weighed 324 tons. You see the marvel of engineering. Due to some reason, in 3rd or 4th Panamax, there were some time overruns. So with one company, we had a tie-up. This portion called green zone, which has got, this is aft of the ship, which has got engine room, accommodation and everything, that was built by the yard. And the other gray zone, 10,000 ton, that was built by some other yard.
Avikshit, may I come in?
Yes, sir.
About 5 minutes, please.
Yes, sir, 2 minutes.
Thank you.
That's it, sir. They were aligned in a float condition and joined. 2 mega block of 10,000 ton and 8,000 ton, they were joined together. Talverkar sir, I always admired you, and today I am admiring you for your timing, sir. You knew when to. Thank you so much, sir. Thank you so much. That's it.
Well, thanks a lot, Avikshit. It was a real good presentation. It reminded me of my days when I spent some time at the shipbuilding center in Visakhapatnam. Certain facilities like, modular construction, laser survey, using of 3D modeling for making even pipes before the outfitting, etc. Certain things were used and they had tremendous impact in reducing the rework. Your presentation was excellent. You covered a variety of areas where the technology can help in improving the shipbuilding life cycle. Certain aspects what you brought out, like Bucky papers, I think these are going to be like, the revolutionary concepts, and they would have a significant impact on the shipbuilding. And so goes, that line heating concept. Frankly speaking, it was an eye-opener for me. And if such things are really used properly in India, it will be good for us. Generally, we have been taking years for ship construction. And if these technologies are used, we should be able to compete with, say, South Korea or China or the world leaders in shipbuilding. So sincere thanks, Avikshit. Real good lecture, and I'm quite touched. I'm very happy. I feel happy that I am here today to hear you and these inputs.
Thank you so
No,
much, sir. आपके चेले हैं, sir. रहेंगे.
That leads me to the next. Now we are going to have our chief guest today, Captain Patnaik sir, my senior in the Navy. And it's a proud privilege for me to introduce my senior to this august gathering. Patnaik sir is a graduate and postgraduate from IIT Kanpur in mechanical engineering, and he done his MBA from Bajaj Institute. He has also done an advanced course in noise and vibration engineering from HMS Sultan, UK. He has undergone a comprehensive course on strategy and leadership at IIM Ahmedabad. He is a fellow of Institute of Engineers India and a fellow of Institute of Marine Engineers. Captain Patnaik sir, during his 25 years of illustrious career in the Indian Navy, he was conferred Vishisht Seva Medal by the President of India for his outstanding service to the Indian Navy. During the last 20 years of corporate tenure, Captain Patnaik has headed production of a strategic project where I had an opportunity to work in a different capacity. He was in Larsen & Toubro at that time. He subsequently joined Pipavav Shipyard and presently is working with IIT Powai in an advisory role in its innovation school. Sir, I'm eager to listen to you. Over to you. Patnaik sir.
Yeah, I'm just trying to share the screen. Is the screen visible?
Yes, sir, we can see it.
Yes, sir, it is.
Yeah, okay. We're jumping into some other slides, so I'm just trying to make it slide number 1. Just to give me a... Yeah. Am I audible, Talwalkar?
Yes, sir.
Yeah. Thank you very much, Talwalkar, for your kind words. And I'm really touched that here is one officer with whom I worked so much closely, and he is the one who is now introducing me. A really touchy scene. Commander Dr. Bhandarkar, Chairman, Marine Engineering Division Board, Institute of Engineers, India. Commander Dr. Avikshit, Guest of Honor of today's webinar and Dean of University School of Management Studies, Chandigarh. Commodore Uday Talwalkar, Moderator of today's webinar and Technical Advisor, Bharat Forge Limited, Pune. A distinguished panelist, Sri Atul Raijada and Sanjeev Mehra, Kenmark Tech Solutions. Sri Mahesh Patil, Marine Engineering Faculty cum Coordinator, Samudra Institute of Maritime Studies, Lonavala, and distinguished participants of this webinar. In the next couple of minutes, I'm going to touch upon primarily on shipbuilding and ship repair. Though Avishit has very vividly covered a lot of good things, what Talwalkar was quite nicely mentioned, and things like line heating and so on. And the technology part, the engineering part, the skill part, and together the leadership part very vividly he has explained. And very nice, Avishit. Thanks a lot. Apart from that, I'm trying to I configured a couple of my thoughts and try and see in some form of slides. It may just give some thought process to our viewers as to what is happening today and what can happen tomorrow. So my basic the thing is, I would like to just mention about the workflows of shipbuilding as well as workflow of ship repair. While considering the workflow of shipbuilding, I wanted to touch upon a total design solution through digital modeling, and thereby going into a modular way of shipbuilding process, which is entirely based upon PLM, a product lifecycle management based shipbuilding. And then I will conclude with a couple of challenges which are there with us, and the possible solutions and additional thoughts. Having said that, the basic shipbuilding flow, as just a recap, we start with concept design, and then we go on to preliminary design and go across to detail engineering with digital modeling, and thereby extract production drawing. This forms a part of the design aspect. The fitting out aspect comes out when you do outfitting at the block level. Nowadays, the concept is to design at the block construction, followed by hull integration and system integration thereof. Thereafter, cold checks, and the difficult part is energization, that is the hot check system wise. This is a part of the fitting out. Thereafter, you get into an harbor trial, and thereafter sea trial, and then post trial system buttoning up, and then flag is hoisted. So this is just being a quick recap. And we start with our preliminary design and go into detail engineering, which is the basic heart of any design center. I have just given as a as an example, you can use Napa and MaxSurf. There are several other softwares which are design softwares available, which need to be utilized when you are trying to do a detail engineering, like PipeNet, and Abhishek did mention about Cadwin, Nastran, ANSYS, and so on. So once you do a detailed design, then you get into a 3D modeling. I have put as a CATIA V5 as a demonstrative software. You can go in for CATIA V5, or you can go in for Nupas Cadmatic. You can go for Aviva Marine, or you can go for Tribon, whichever software suits you for shipbuilding. You can use and put all your design aspects, all your components, sub-assemblies and assemblies in a 3D model, wherein you do a proper analysis of the interferences involved. You take a rule-based approach, wherein you freeze the model in certain form. And then thereafter you present it to the customer through a virtual reality scenario. This is a very important aspect, where you need to take the customer along with you, take customer feedback on various aspects, tactical, operational, and so on, which I will come to now very shortly, and freeze your 3D model, lest you may land up in rework later on when there are modifications suggested by the customer. So once you go through this virtual reality scenario, which is a very done thing nowadays, though virtual reality, formation of a studio, and then going through walkthrough models, etc., it is a little expensive, but yes, I think it pays back enormously when it comes to shortening of your cycle time and cutting down on your rework and so on. And once you finish your virtual reality walkthrough model, come to put everything into what is called VPLM and PLM database. So in the project lifecycle management, you need to once everything is put in PLM, it has got a strength. I mean, you can use Matrix 1 as a PLM software, or you can use Innovia or Windchill, Teamcenter. I mean, whichever way you think it is appropriate for your system, you use a PLM system. And basic thing is you need to be able to extract BOM, that is the bill of material. You need to extract production drawings. You need to configure complex jigs and fixtures for major equipments installation. You should be able to extract isometrics. You should be able to find out which are the salient shipping in routes. Having got these things, moving further, these are the couple of glimpses of 3D modeling, what you're trying to do, wherein you do the interference analysis, which is the very first one, what I could see. You can also configure the shipping in and shipping out routes, and which will come out through a PLM platform. And once your 3D modeling is frozen, this is how it will look. I've just given a sample, and particularly for major equipments, it's very vital. And this is the third picture here gives rise to all the kind of sequencing, which is very important. And the jigs and fixtures which are required for major equipment installation, walkthrough model through the virtual reality, and lastly, the accessibility check. It is very important because once you finish your modeling and then start extracting production drawings, and then thereafter, once you install the equipments and you see the equipment cannot be accessed in a given compartment, then there you will end up in a problem. So, so these are the couple of salient features what I have envisaged, which will come out of 3D modeling. And 3D modeling necessarily will have to be rule-based. For example, I've just given an example, a gap between a hot pipe and a cold pipe should not be anything less than 200 millimeters. If it is less than 200 millimeter, it pops up that there is going to be a remodeling. But at the modeling stage only, you follow the rules and design your, and you position your pipes. The second the slide which is shown here is the distance between your cables and vibrant pipes. So that the distance should not be less than 50 millimeters. But if it is less, while doing modeling, if it is less than 50 millimeters, then you have a problem. So that's why at the modeling stage, you follow the rules and do the modeling in a given space. And this is the summary of what you do from the system schematics. You do a modeling, then a progressive build up of a compartment. You start filling up the compartment, while doing the filling up the compartment through a 3D analysis, you focus on interferences and accessibility, etc. And so once that is done, and the customer feedback is also incorporated, then you start extracting production drawings, bill of material through PLM. And for a total digital solution, from basic design, go to modular design, thereafter 3D modeling through CATIA or any other software equivalent to CATIA, Tribon, etc. BPLM and the PLM. PLM will have two components. One is the project management, where you need to see the progress of the project. You can use Concerto as a software, or a Primavera, or a MS project, anything you need to do. But yes, project management is a must. And enterprise resource planning, particularly for your material which is flowing in. Normally, I mean, most of the shipyards use BAN, but any other software could be used for your addressing your ERP issues. This from the 3D model basket, you can go in for equipment installation through a proper design of jigs and fixture. You can go for pull out pipe isometrics, which can be directly fed into a CNC machine, and you get the pipe spools for installation. And similarly, you can get your type of cables and the length of the cables and the routing details for cable laying, because any ship construction equipment, etc., normally gets addressed properly, major, medium, and minor equipments. Where you get struck is when you lay out pipes, cables, and trunkings. That is where you have clashes. And therefore, you have to have a seamless integration of design and engineering with production. And I was mentioning to you about the virtual reality. You have to take customers' feedback as far as the design is concerned, option analysis is concerned, system integration is concerned, maintenance envelopes are concerned, tactical and mission rehearsals are concerned, operational analysis. So all these features, you have to have a proper sitting with the professionals of belonging to the customer sector, and their feedback are very important when it comes to final freezing of the 3D model. Without therefore, this virtual reality, what even Abhishek was mentioning, VR and AR is very, very significant component in shipbuilding. Though it is little expensive, but once you have this particular tool, it makes your life much more simpler in terms of reducing very heavily on your rework. Now come to modular construction. I have just given a very a picture of just to understand the thing. I have broken down the entire ship into 3 sections: the forward section, the mid section, and the aft section. And once you depending upon the kind of ships you are building, let's say you are building an LPD, it will have probably 27 blocks. I have just given a figuratively 3 blocks, but each block, once you configure this is the block, that means you build it anywhere. And this concept is that suppose you have got one mother shipyard and you have got 3, 4, 5 ancillary shipyards around you. You can take these blocks and build them at any of those ancillary shipyards and then bring them to the mother shipyard for assembly. So build anywhere and assemble at a given particular place will be the concept, but your design will have to adhere to the blocks what you are building. And here there are distinct advantages. Naturally, you will have a parallel construction, thereby your entire cycle time gets compressed, and each block has got its own identity. It's backed by its sound design, it's backed by its own 3D model, and you build the block and bring the block in, and then join the sections to make the vessel. So this is the summary of modular design. It has to be designed in a modular way, and the sections are fabricated separately. The major assemblies and sub-assemblies are also fabricated and tested separately. Thereafter, these all the deck sections is called MIDS, that is the modular isolated deck sections. They're all slid into the sections, and they're all housed in there. A couple of snapshots Abhishek also has shown in his slide, that how the decks gets fitted into the blocks. And once they're all secured and the block is ready, then the sections are joined at a given place to form the vessel. So the basic point is that the design, you need to design the way it is built, and everything is now centered around the PLM, that is product lifecycle management. And our goal should be build the right product and build the product right. So obviously it's a big challenge to do everything first time right. Therefore, we need to adopt to a lot of not only digital mockups, but you need to do a lot of mockups outside the vessel, so that your fitment or your weldment or your whatever you are doing it on board becomes almost flawless. I will not say with 0 errors, but there will be certain things, but rework gets minimized. Therefore, a lot of emphasis is required to be made on mockups. And this will give rise to finally a digital manufacture, which are totally PLM based. This is some snapshot of a 3D design going through virtual reality. So three mantras which are there as far as the basic usage is concerned is OMA, that is operability. You should be able to operate a particular valve or a particular pump easily in a given compartment. You should have a sufficient maintenance envelope, so that should there be a maintenance requirement on board, you should have a sufficient maintenance space to maintain those equipments or components. And thirdly, you should have an accessibility to operate those particular equipments. And primarily, sometimes we overlook, but at the design stage, once these OMA are taken care of, I think the amount of which are rework which is required gets minimized. And through PLM, you have a concurrent design and a revision control. More often than not, what happens is you get an R1 or an R2 when you are halfway down the production and R3 flows in. That is a disaster. So we have to see that latest drawings are available on the shop floor, and therefore a very sound revision control of the drawings is required. And that is where the PLM really helps you to have a proper revision control and concurrent engineering. So all the integrated digital environment what we are creating here, it would only ensure the right product is built with the right bill of material, the right quality standards, and right system level requirements. That is the final aim of the entire exercise, what I was trying to explain to you. On the PLM, I think it's just a slide. PLM actually, it improves the planning and scheduling. It definitely substantially reduces the quantum of rework, and it shortens the time to production. And it always has a system-centric approach, and thereby you can adopt this principle of build anywhere and assemble anywhere approach. And all this normally gives a competitive advantage when you have a lean manufacturing practice. When it comes to ship repair, a quick one, I think we crossed 8:30, another about 3 minutes I will take. On ship repair, the workflow is known to most of us.
Sir, you can continue, sir. We are enjoying your presentation. There is no problem. You can continue.
Okay. Right. So on the ship repair front, we need to do a thorough defect analysis. That is where, I mean, I'm only stressing on the points which by and large, we take it for granted and baad mein dekha jayega type of attitude we follow. But ship repair is basically a murky game. If you are careful in the beginning, I think it becomes a smooth sailing later on. So when you do a defect analysis on hull, engineering, electrical, and W&S, that is weapons and sensor, on both the aspects, afloat condition as well as in the underwater condition, dry dock conditions, this analysis is important, and this will give rise to your spare parts requirement. So spare parts identification and spare parts aggregation, I think it is the heart of the entire ship repair process. I think Mr. Rajada and his colleague was mentioning that how difficult it is to recondition the entire things. And when you do not have spare parts, cost part, barring the cost part, it is very, very difficult process. And therefore spare part availability at the right time for the ship is very important. And be it a material organization, be it from the OEM, spare part identification is a task by itself. Having done that, you also need to identify specific tools and tackles. For example, there is a propeller removal or a shaft pull out or a main engine lifting. You need to have the tools and tackles meant for all those specific purposes, which will come out from the first point, which is the from the defect analysis. You know what defects, what major defects you're going to handle. And then you have to resort to a 3D model, which is already there during the ship construction time, but during the off cycle, there are some changes in the compartment. There are changes in the systems. So you need to rescan preferably and get a 3D model compartment-wise established. Thereby what happens is your dismantling and reassembly becomes that much simpler. Otherwise, you will end up in problem. Then you go to see the repair in a shipyard workshop or OEM premises or outsourcing. That aspect you need to be very clearly mentioned, put it down in a piece of paper. Testing and tuning and the workshop, and onboard fitment, therefore, putting last out and first in principle, and followed by test and trial. These are the basic rudimentary workflow for a ship repair. Bringing out some salient difference now, having talked about new construction and ship repair. New construction, what is more structured, drawings are verified, but when it comes to ship repair, the system drawings undergo a lot of modification during off cycle. You need to be careful about. So I'm putting down about half a dozen points which we need to keep it in mind. When it comes to ship construction, sequencing is more systematic and have got a better control over it. And in case of ship repair, it is bit of a more of randomness is there. Depends on the nature of the defect. Which engine is to be lifted out, which pump need to be in situ repaired, which pump has to be taken it out. Certain amount of randomness is there. And here is technology is well established in case of new ship construction, whereas in ship repair is more of you resort to more of firefighting and more challenges are there. In ship again in new construction equipments, they undergo FATs at the factory. Not much problem on spares because it's all new engines which are with new pumps, new equipments which are already tested. You need to be only installed. Whereas in case of ship repair, you require defectation largely involves uncertainty of spares. That is where I should have highlighted is in red, but uncertainty of spares is always a problematic feature in any case of ship repair. New construction, major equipment installation is well sequenced, whereas in case of ship repair, overall entails a ship side cutting, let us say, then you need to then you have to be careful about consequent distortions, hull distortions. In case of new construction, deformations and distortions can be well managed. Whereas in case of ship repair, if there is a major hull work is there, it results in deformation. You have to be really, really careful about it. When it comes to ship repair of warships and commercial vessel, again, there is a difference. Warship cases may the sequence of dismantling and reassembly is a big challenge because of space constraint. Not so much a problem in case of a commercial vessel. It's comparatively easy. Warship PPM routines and defectations are very rigorous due to ship's role, whereas in commercial vessels, routines are little more relaxed. Defectations is largely by OEMs. Warships systems are very complex. Commercial vessels systems are relatively straightforward. Warships systems consist of hull engineering, electrical and electronics, weapons and sensors, and aviation. Whereas commercial vessels are restricted to hull engineering, electrical, and nothing else, no aviation, no weapons and sensors. Warships, however, you have a challenge on thin hull structure. So any rectification involves distortion. You got to be very, very careful. Whereas commercial vessels on hull plating, no major problem can be envisaged. Lastly, warships is comparatively less problematic on tanks. But whereas in case of commercial vessels, when huge tanks are there, the tank cleaning and gas free is a major challenge. So ship repair, the challenges which are there, I'm just put my thoughts into this. There may be very many more challenges, but accuracy of digital prints is very important. If you do not have a proper digital print of a particular compartment wherein you are having a defectation, you are running into problem. You definitely will run into problem when it comes to dismantling and reinstallation. Therefore, it is better that you scan the compartment through a laser scanning. You have a Faro, etc. And normally, it is recommended that shipyards who are undertaking ship repair should have a facility for a digital scanning like this. Other challenge is unshipping through ship side cutting. If you are unshipping major equipment through ship side cutting, you got to be careful about consequent distortions. Timely availability of spares and components. I should have put this particular fourth point as the first point, but this has to be of paramount importance of availability of spares and components which are required for the ship repair. Skill set. Abhishek did also mention about skill set. When it comes to ship repair, let us say main proportion alignment, weapon alignment, hull machinery, etc. You need to have a proper skill set, and therefore the training also you can't overemphasize on the training aspect. Training is a continuous process, no doubt, but training of the manpower is definitely a must when it comes to ship repair. Expertise in piping, trunking, cabling, no doubt, it has to be there. Main and auxiliary machine overhauling expertise is required. Repair workshops. I mean, you need to have workshops which will cater for repairs of hull equipment, engineering equipment, and electrical equipment. And having said that, you must also have testing and tuning facility. Even for weapons and sensors, you need to gear up in terms of having your own workshops and labs. And creation of testing facility, particularly for high pressure areas, underwater wall testings, hull equipment testing, electrical equipment testing, you need to cater for these testing facilities. When it comes to shafting, if there is a requirement of two-nest checks, yes, you need to have facility for that. Balancing of propellers, static and dynamic balancing facility you should have. ICCP facility you must have, cathodic protection. Then system buttoning and system integration. It's again a specific skill set which is required to be taken forward, because this is the last phase in any kind of ship repair phase. Onboard pressure testing, that is air pressure testing and hydraulic pressure, is a big challenge. And finally, cold checks and hot checks will have to be done for energizing the system. Solutions, I have just put down a couple of solutions which came to my mind. Obtain digital footprint of machinery and systems after the pre-refit trials are over. Accuracy is very important in this particular aspect. Based upon the defects, you need to decide upon sequencing of dismantling that need to be ascertained. You can adopt the principle of first out and last in. Major equipment overall, you need to pull out major equipments from the ship and send it across to OEM. That may come into the critical path because the equipment has to travel to the OEM premises. OEM has to do a major overhaul. OEM has to do its own FATs, and the equipment has to travel back to the ships to the ship installed, and the soft patch or the ship side patch has to be welded. So in order to avoid that such a thing to come into critical path, you need to pull out the major equipment, send it to OEM. Mustering of all essential spare parts, components of assembly, very important aspect. You need to stick to that. Strict monitoring of outsourced activity, which are being outsourced both in terms of quality and on-time delivery. Normally, हम बोलते हैं ठीक है आ जाएगा, but no, we need to have a ship repair monitoring team for outsourced activities. Those components, sub-assemblies need to be delivered on time with quality check. Repair facility. Normally, I'm assuming that a ship builder will also have facility for ship repair. Under those circumstances, which is a very favorable circumstances, you have created a facility for ship repair. Then you need to see that you have minimum dependence on the new construction workshops. Yes, for shaft two-ness check, let us say you need to have a single facility. You need not duplicate. But there are normal routine things which are there. You need to create a separate workshop so that there is no interference between the ship construction workshop and ship repair workshop. Commercial vessels, more structural repairs are there. Focus need to be there on structural repairs than equipment repairs. Equipment repairs, mostly it's OEM centric. And continuous training of workers and supervisors. I needless to emphasize on this. You need to have a training as a continuous process. Then you need to also have a facility for dust-free environment for weapons and sensors and electrical components and high-pressure systems. System integration, I am also mentioned, I'm re-emphasizing system integration is very critical. And that is where we have stumbling blocks. Cold checks and hot checks parallelly, you can always have it. DG trials and hull equipment trials also in parallel with main propulsion assembly. Thereby your cycle time reduces, cycle time for repairs. I have put down this slide, it is food for thought. I have put down 40-30-30 principle for ship repair. 40% being a repair philosophy. This is a kind of a repair philosophy. You may have a different repair philosophy. To me, it looks to be 40% you do it in afloat condition, followed by 30% in dry dock work package, and the balance 30% is post dry dock, including trials. You may think that within a given dry dock, I will probably enhance my dry dock percentage. We may have 40, 40, 20. It is up to the shipyard. But to me, and with my experience, it appears to be 40, 30, 30 is a very kind of an optimum repair philosophy, but it is again a food for thought. These are additional thoughts I'm leaving behind before I conclude. Shipbuilder also entering to ship repair is always advantageous. And I think nowadays we are seeing any shipbuilder going in for both new shipbuilding and ship repair together. And it is even more advantageous if the shipbuilder gets the same platform with the systems for ship repair, because the entire the culture, already is there with the shipbuilder for repairing the ship if it comes after a couple of years. Few basic workshop facility could be extended for ship repair. So that means, as I mentioned to you, that you need to have certain workshop facility from the shipbuilder could be extended for ship repair, like let's say propeller balancing or main propulsion shaft, two-ness check, and so on. Shipyard should have a digital scanning. I've mentioned to you, I've given example of Faro scan, which is a beautiful thing. You must have a laser scanning, and the digital scan of a particular compartment will smoothen out your life tremendously. And it also would create some reference points on board, which gets disturbed over a period of time. That is required very much for calibration purpose. For commercial vessels, when there are large scale hull plate renewals, etc., use of robot. Abhishek did mention about the usage of robot. I fully in agreement that if you have a robot, it will definitely improve accuracy as well as speed. I think we may consider the incorporation of a robot. Yes, ship side hull cleaning, etc., could be extended, but I am only focusing on the hull plate, which does take a lot of time. Excuse me. In conclusion, for new ship construction, 3D modeling should be rule-based so that you don't make any mistakes. And this 3D modeling should pass through virtual reality, which is a must to get customer inputs prior to production. Sorry, excuse me. And this, when you go through this particular methodology and you carry out certain mock-ups which are necessary, that would avoid rework. And if it avoids rework, just imagine how much time you reduce, cycle time you reduce towards production. And cost overruns and time overruns substantially gets addressed when you do the mock-ups. Sometimes हमको लगता है कि mock-up करने में इससे waste of time. Let us go on board and do the thing and finish it off. But if you land up in having problems, let's say a particular pipe welding, you land up in having defects it doesn't get RT cleared, then you land up in straight away in rework. Therefore, if it is a pipe welding through an orbital welding which you're doing on board, do on a mock-up. The same welder should be feeling confident that when he goes on board, he does with 0 defect. You get an RT cleared, totally RT cleared fill. So that's why this third point, mock-ups are necessary to avoid rework, is a point which need to be addressed and remembered in shipbuilding. And needless to say that the entire manufacturing process should be PLM based, and with an ultimate aim that it should be first time right culture should be followed. And then if above 4 are followed, definitely you will end up with the first time right principle. But in case of ship repair, it is rather a murky game, and you have to be very, very careful there. And in terms of sound planning is required, that is must. And timely logistics support, I'm re-emphasizing that timely logistics support is necessary. And thereby your sequencing of dismantling and reassembly should be carefully implemented through your digital print. Once your digital print is all right, then your sequencing will come out in place. And lastly, again, in case of ship repair also, first time right culture should be the motto in SR space, ship repair space. I have finished, and I think I've taken little extra time than our stipulated finishing of 8:30. But any of you have got any queries, etc., I'm available on my gmail.com, patnaik.siba@gmail.com. If any queries are there, I will be very glad to answer any of your queries offline. Thank you very much. Thank you once again. Jai Hind.
Thank you very much, sir. It was a real nice presentation, and you had covered two very significant aspects, shipbuilding and ship repairs. Both appear to be same or similar, but there are their own challenges, and you have aptly brought it out. Your recommendation that the shipbuilder should also have a ship repair facility is a real good one, and possibly things are moving in those directions, but we need to have more efforts towards this. You had brought out certain important points with respect to shipbuilding, the necessity of virtual reality walkthrough, 3D modeling. I don't mind sharing my experience that I have been immensely benefited by the 3D modeling, particularly when we are looking at the outfitting of a strategic platform, a follow-on strategic platform, and it had really helped. There was significant reduction in piping rework, cabling rework. In fact, the advantage of this was the interference between equipment installation was addressed at the 3D modeling stage itself. And sir, but I'll also like to highlight one aspect which maybe you might have missed out by oversight. The 3D modeling also helps us in coming out with optimized outfitting sequence. Yeah. Like for example, if a particular equipment is to be installed, you know its dimensions. And then based on that, you can decide which equipment has to go in first. Particularly, certain things have to go on the, say, ship side, certain things will go at the bottom. So the 3D modeling we can effectively utilize to optimize our outfitting sequence. And you very rightly brought out that build right the product and build it right. This philosophy, as well as first time right, these are very essential requirements which we need to follow. In fact, if certain these technologies are used, our shipbuilding time can significantly get reduced. While coming to ship repairs, you did bring out the nuances of shipbuilding, ship repairs, and the need to have a very good project planning there. The idea of 40-30-30 repair philosophy is quite a good idea. And I think if it is passed down to our naval dockyards, probably things can be a little better. So, sir, it's good. I mean, you covered both aspects really well. The complete spectrum has been covered nicely. So, sincere thanks to you.
Thank you. Thank you very much. Thank you.
Bhaskar, may I summarize all the presentations?
There are few questions, very important. You can take those questions in question answer mode. Otherwise, shall I take? First question from Ravindranath. He is asking availability of 3D printers in shipyard. Patnaik sir, with your rich experience, can you answer this?
Yeah, I think you see what Ravindranath is mentioning, that 3D printers already available. He's asking that. This much I know. I mean, that a couple of shipyards, they have a facility for virtual reality studio. And shipyards like L&T, etc., they have a Faro scanner where you can print on a three-dimensional thing on the equipment, footprints, etc., compartment layouts, and they've been extensively utilized. I'm not very sure about other shipyards. I myself has used there's a Faro scanner on a strategic project, which is of immense help. It gives immense help, and not only that, even the Faro scanner, in addition to 3D printing, it also helps in fixing the reference points, which are very, very important. It is very important on strategic vessels when it comes to calibration.
May I also come in? There are some inputs with respect to repair yards. The 3D printing technology is relatively new, but the Navy, Indian Navy, is going ahead with these 3D printers, and certain repair yards like Naval Dockyard Visakhapatnam, Naval Dockyard Mumbai, they have introduced 3D printers, but it is at a nascent stage and it's long time to go to make it fully usable.
Sir, here I will like to bring in, when we speak about the emerging technologies, they all are at their nascent stages. Some portion of some technology is being used somewhere. It will take, say, 5 years plus for the whole technology to mature and to be universally implemented. 3D printing is one of them.
Due to constraint of time, we'll take one more question. Others, they can contact the respected faculty.
Yes.
This is from Dr. Sridhar Kasturi Rangan. He says, thanks for excellent and informative session. I would like to know whether laser cladding alloying is being employed in repair process, as this process leads to high performance process. Anybody from the panel, please.
I think we'll need to study it in more detail. This offhand answering such a specific question will not be in order unless at least I know it. I will not like to comment on this.
Sir, laser cladding basically is being used, but in a limited way. Uh, Firstly, it's very, very expensive. And secondly, you cannot employ all positions of welding on it. There are a lot of restrictions to it. So I think for the repair industry, we will have to wait for some more time for the prices to drop down to be economical for us to, buy such heavy priced equipment and use it. So there are little challenges in using laser cladding.
That application was specifically for hydraulic cylinders, So anyway, what Sanjeev sir has told is perfectly applicable. Yes.
This was a good session so far. May I request Commodore Uday Talwalkar to kindly sum up, please?
Thank you, Bhaskar. Can you hear me?
Yes, sir.
Yeah.
Yeah.
We are loud and clear.
The Marine Division of Institution of Engineers is really doing well. A number of seminars have been organized, and it is the personal, leadership of Bhaskar, which is responsible for this. And I must thank Bhaskar for such a nice, apt seminar being organized. I'll tell you why it is apt. Currently, post-COVID, our economy is going up. For us, shipping is important. And shipping is not only related to the ocean going shipping, but shipping for inland shipping is also important for us. And from that point of view, we need to look at improving our shipbuilding capability, bigger vessels, smaller vessels, and also pay attention to the effective and less time consuming, less costly repairs. So in that context, this is a very apt seminar. And Bhaskar, thanks to you for this. We had very distinguished speakers today, Mr. Mehra and Mr. Raizada. They really covered in detail how things are to be, how things are repaired, particularly for diesel engines. They showed certain large number of photographs of damaged components, and their philosophy is not to throw away the part, but to repair it, reclaim it, reuse it, so that the cost to the company reduces and also the time on task also reduces. Certain repairs which are done in situ, like grinding of crankshaft, etc., are quite innovative and also leads to timely availability of the vessel. While we should appreciate and the efforts put in by them for repairs, we also need to pay a heed to very subtle instructions given by them for following the SOPs and following hygiene, maintenance, etc., so that the need for defects or the root cause of defect be minimized, if not eliminated. Coming to the next lecture by my colleague Avikshit, he brought out technology, engineering, skill, and leadership. The leadership is very, very important, and without leadership, no technology can help us. So thanks, Avikshit, for bringing out this important aspect. He did bring out certain other technicalities like need for 3D printing, robotics, virtual reality, augmented reality. Then he also introduced something like fuel optimization system, the concept of Bucky papers, which probably is going to change a revolutionary change in the shipbuilding philosophy, line heating, and then his mentoring by his Japanese experts. A real good presentation. And his presentation, which if we combine with the presentation of Captain Patnaik, that becomes a very wholesome, approach for technology, how technology can be effectively harnessed for shipbuilding as well as for ship repairs. Patnaik sir covered workflow in shipbuilding, need for digital modeling. In fact, his emphasis on getting the 3D footprint of a compartment, functional compartment, particularly in the context of ship repairs, is very, very important. And the decision makers should take a note of this. Regarding the 3D modeling, very certain, important aspects like interference resolution, effective piping layout, effective cable layout, then ensuring that the maintenance envelope is available, marking shipping and shipping routes. All these things are possible if 3D modeling is done, and 3D modeling can really effectively enhance our throughput for shipbuilding. He also highlighted the concept of modular construction. And in fact, he brought out one very important point: build anywhere and integrate at one place. If this philosophy is adopted, you can imagine how drastically we can reduce the shipbuilding time. There can be huge amount of concurrency, and which will actually lead to reduction, significant reduction in shipbuilding time. One more aspect which I will like to draw attention of this August body, what Patnaik sir brought out, is the system-centric approach. Generally, in shipbuilding practices, we follow drawing-based completion approach, because the payment is related to so many drawings completed, you get payment. These are milestones. But then when it comes to the acceptance agency or the customer, for him, availability of a system is more important, because when a system becomes available, he can commence certain setting to work or fleshing through, or tests and trials he can commence. But then there is a conflict between the system-centric approach and the drawing completion-based approach, and we need to draw a good trade-off, a well-agreed trade-off in both these approaches. Patnaik sir also highlighted certain nuances of ship repairs. He highlighted the need for a very sound project planning when it comes to ship repairs, because in ship repairs, in his philosophy, if I say so, it's a murky affair. Yes, it is. I mean, rather than murky, I'll say that it's a fairly complex and challenging affair as compared to shipbuilding. The ship repair poses its own challenges. Availability of logistic support, spares, tools, trained manpower are very important, and huge amount of pre-planning, far much more in detail and far more in complexity is required as compared to shipbuilding. So sir, thank you very much for very illustrative lectures. And all the panelists have done a real good for this. And again, thanks to Bhaskar for having such a nice, apt webinar conducted. Thank you very much. May I now request Bhaskar, now we are going for vote of thanks.
Sir, you are mute. You are muted, sir. Bhaskar, sir, you are muted.
Yeah, I request Mr. Sudeep Chakravarti, Director in charge Technical Institution of Engineers, to deliver a formal vote of thanks.
Thank you, sir. Good evening, everybody. I feel honored to get this opportunity to deliver the vote of thanks in presence of all the dignitaries who are doing in their own domain. First of all, I express my thanks on behalf of III to Captain S.K. Patnaik, Advisor IIT Bombay Innovation School, and Professor Commander Dr. Avikshit, IN retired, now Dean Management and Commerce, Royal Vihara University, Chandigarh, for sparing their valuable time and accepting our request to grace the function as Chief Guest and Guest of Honor respectively. Thank you, sir, for a very thought-provoking and interesting address. I also thank our distinguished speakers, Mr. Atul Mohan Raizada, founder, Kenmark Tech School, and Mr. Sanjeev Mehra, Managing Director, Kenmark Tech School, for their excellent presentation and making this seminar a very meaningful and interesting by enlightening us on the latest technology in shipbuilding and ship repair. I did like to express my deep gratitude to Commodore Udayshi Talvelkar, Technical Advisor, Bharat Forge Limited, who was the moderator of today's function, for conducting the session smoothly and summarizing the session proceedings. My sincere thanks to participants for their patient participation, without which this webinar would not have been a success. I also thank our chairman, MRDB, Commander Dr. Bhaskar M. Bhandarkar, and K. Bindu Mahan and Dr. B.K. Saxena, members MRDB, for guiding us to make this seminar or webinar materialize from the conception. Last but not the least, I thank our team technical department at II headquarters for all their effort and dedicated service put together to make this webinar a success. Thank you once again to all.
Yeah, we thank Mr. Mukesh Patil, Dean Marine Engineering Faculty Samudra, for his presence and initial remark and on the theme of webinar. May I request all the panelists to switch on their video so we can have a group photograph, please. And Mr. Sundip Chakravarti, will you do the honor of taking this snap of the panel?
Yes, sir.
Can you do? Yeah, please. So may I
Greetings,
request all the
everyone.
panelists?
This is already
Nice
recorded,
to
sir.
see Captain Patnaik.
Hello. Hi, hi.
Rajendra sir, Rajendra sir, remember me? Great to see you.
Yeah.
Okay. Thank you very much. Thank you for esteemed presence, and it was a wonderful webinar.
Sir, we have the full video recording of the proceedings. If anybody wants, we can share it.
Yeah, yes, sir, kindly, we shall, I mean, I will be grateful.
Yes, sir.
I can show it to my students. They will be
Yes,
highly
and
benefited.
this is also available in our YouTube link also.
Okay, great, sir. Thank you so much. Thank you so much.
If it could be shared to in our respective mail IDs, it will be nice.
Yeah, I'll share
Sure,
it.
sir. Yeah,
I'll share it.
Thank you
I'll
so
share
much.
the video and the YouTube link also.
right.
Right.
Thank you very much.
Thank you very much. Thank you very much.
Thank you.
Good
Thank
night.
you.
Thank you, sir.
Thank
Thank
you.
you.
Talvelkar.
Jai Hind.
Thank you. Thank you very much, Abhishek.
Thank you,
Thank
sir.
you. Thank you. Thank you, Saxena Sahab. Nice
Yeah,
meeting
good.
you. Thank you.
Nice seeing you after.
Yeah, after a long time. Yeah. Thank you. Bye-bye. Good night.
Good night. Good night.
Good night.
Thank you, Bhandarkar. Thank you.
Thank you, sir. Thank you, sir.